In today's video, here is a nice problem from Indian Mathematical Olympiad edition 1990. Here is the following information. Our goal, we are going to find all non-negative integers a and b satisfy this following equation. Okay, we have eb minus 7, all is raised to the number 2 as a power, equals the sum of the two squares, a square plus b square. So generally, I'm not going to use the modular arithmetic. We are going to use some tricks. We are going to transfer this one into inequality. Okay, so I found this is the best way to solve this one. You guys, you can check the different way of solving this one. So before we move on to the solution, don't forget to support the channel. So now let's go ahead and get started with this one. We are simply going to take the obvious solution here, because if a equals 0, this one will be 0. I will be left with minus 7 square, which is 49. I get this one 0. I get b square here. 49 equals b square. B equals 7 because we have positive integer. Okay. So we get here a equals 0. B must equal 7. So again, this equation is associated with a symmetry here because we have the e square b square and the product ab. So they are playing the same role here. So which means I'm going to take another copy of the solution. So a equals 7 and b equals 0. Also, I'm going to add the second value. So we are going to check a equals 1. Equals 1 here, equals 1. I will get here b minus 7 square, which equals 1 plus b square. Okay, I'm going to expand this one out. I get b square here, minus 14b plus 49, which equals 1 plus b square. Cancelling out b square from both sides, I will be left with minus 14b, which equals minus 48, because I'm taking 49 to the right. Cancelling this minus with this minus, dividing both sides of this equation by 2, I get 7b, which equals 24. b equals 24 over 7. But this one is not integer. For a equals 1 or b equals 1 is not a solution. Okay, now let's move on to the general case. In this case, we are going to consider if a is super equal to 2. Okay, without loss of generality, let's assume a is inferior equal to b. So which means we will have two cases. We have a equals b or a is strictly inferior than b. So if a equals b, I'm simply going to replace b with a. I get a square here, minus 7 quadratic square equals 2 times a square. Okay, if I'm going to take the square on both sides, I get a square minus 7 equals square root of 2 is multiplied by a. So we get the left hand side of this equation is an integer, but the right hand side of this equation is not integer or natural number, whatever. Okay, which means the case equals b, it's impossible to be a solution. Okay, now let's move on to the, now let's take this equal sign, let's leave strict inequality like this. The best way to solve this equation, I'm going to transfer this equality into inequality, because I will have something more complicated if I'm going to solve this equation in terms of a and b. So I'm going to make it more simple here. So we know a b minus 7, which is quadratic square, always we get 0 is inferior equal to this one, and we know this one equals to a square plus b square. We know the sum of these two squares is always inferior equal to a plus b quadratic square, because if I'm going to distribute this one is given as a square plus 2 times ab plus b square, since we are dealing with the positive values. Okay, then again I'm going to, since we have this one and this one are positive, I'm going to take the square root on both sides. Then this square will be cancelled this radical, so I get ab minus 7 is inferior equal to a plus b. Okay, don't forget we have a strictly inferior than b. If I'm going to add b on both sides, I will get this one is strictly inferior than 2 times b. Okay, then I'm going to move over this 2b to the left side and bring back number 7 to the right side, and take the b as a common factor at the same time. So we get b here, factor a minus 2, which is strictly inferior than number 7. It's more clear here. Taking minus 7 to the right and bring this one back to the left, then take b as a common factor. Also, this one is strictly inferior than a factor a minus 2, because we get a strictly inferior than b. Also, don't forget this one is always positive, because I have a is super equal to 2. If I'm going to take number 2 to the left, I get a minus 2 is super equal to 0, which is true. Okay, then multiplying by a is going, this product must be positive. So now I'm simply going to bring this number 7 to the left and solve this quadratic equation. So I get the following. I get a factor a minus 2 is strictly inferior than number 7. So I'm solving this inequality by taking number 7 to the left. I get a squared minus 2 times a minus 7, which is strictly inferior than 0. Okay, let's define a function f of z, which equals z squared minus 2z minus number 7. Okay, if I'm going to solve this equation, it's going to give us, I'm not going to calculate these things here because it's normal calculation. So when we calculate this one, we will end with this one. Z is going to be like 3.8. Okay, like this. So now I'm going to put this one into the graph in order to determine the region of the solution for this function. Okay, when this function is crossing, for this equation, when this function is crossing the horizontal axis. So I get the following. Let's take the general picture of this one. So the general picture will be like this. Because since we have minus 7 here, this one will have upper face parabola. It will cross the horizontal axis at certain points. It will cross it at 3.8 because it's a solution for this equation. So we'll have 3.8 here. Then we are dealing with a. So for all z must be super equal to 2. So here is a number 2 here. If this one is number 2, so I'm taking just this one as a approximate values. Okay, so the solution for this equation, it will be on this region. Since we are dealing with integers, so z from this interval 1, 2 and 3 only, because we have 3.8. okay, so we'll have less than this one. I'm going to take the value less than this one, which is 3, and include number 2. okay, now let's get rid of this one and move on to the solution. Previously we have determined this following values of a as a non-negative integer. We found 2 and 3. So let's go through each case. A equals 2. Okay, so I'm simply going to replace number 2 into this one here. So I get 2b minus 7 quadratic square, which equals 4 plus b square. Okay, let's distribute this one out. I get 4b square minus 28b plus 49, which equals 4 plus b square. Okay, one of the b square will be cancelled out. I will have 3b square minus 28b, 49 minus this number 4 is giving us 45, which equals 0. Okay, now I'm not going to use the delta, I'm going to use modulo arithmetic. Since we didn't use modulo arithmetic in this problem, so I'm going to use it here. Okay, so you know 28 is divisible by number 7 will be 0. Okay, always try to find appropriate modulo where we can reduce your equation, because so especially in the middle term we have b, because we don't know this b how is going to be. So always try to make the middle term 0 here, since we have b here. So leave this one, because this one, it's more known values is a b square. It's more known modulo for this one. So reducing this one to mod 7 will be 0 here. So I get here, this one will get 3b square, this one 0, This one 45 is the same. We know 45 is 42 plus number 3. 42 is divisible by number 7, so I will be left with number 3 as a reminder, which is congruent to 0 mod 7. Okay, it's more clear. So I'm going to take number 3 as a common factor here. So I get 3 factor b square plus number 1 is congruent to 0 mod 7. Okay. We know 7 not divides 3, which means 7 divides this one. In the other word, b square is congruent to minus 1, which is congruent to 6 mod 7. So I'm not going to go through the chart if I've been using the chart a lot. So if you go back to my previous videos, you will see the examples when you reduce this one to the mod something by using the chart. So we know when we have the perfect square for the integer, reducing to the mod 7, always we get, for example, the capital X square is congruent. Always you get 0, 1, and 2, and 4 only mod 7. Okay. So, but we get number 6 here, which is, we don't find number 6 in this set, which means we have no solution for this equation when we have a equals 2. So simply you can use a delta, you will find it's impossible to have no solution. Okay, so I'm using simply the modular arithmetic. Now let's move on to the next case when we have a equals 3. Okay, now for a equals 3, I'm simply doing the same thing here, replacing number 3 into a. I get 3b minus 7 quantity square, which equals a square, which is 9 plus b square. So simplify this equation, I get 9. So I'm going to divide both sides by number 2. I get 4. I'm not going to use any modular arithmetic because I know we have a solution for this equation at some points. So we don't want to make the equation complicated. Just simply calculate delta. What we end with, we will be end with b must be equals 4. So we will find another solution, but that solution we will find the second solution for this one, because we have a quadratic binomial equation here. So the other solution will be not integer, so we are going to take only this one, b equals 4. Okay, so which means we have the following solution. We get a equals 3 with b equals 4. By taking the copy of the solution because of the symmetry, we get a equals 4 and b equals 3. So we get these two solutions plus these two solutions. So the total, we have 4 solutions for this equation. Okay. So by the way, so I have ended this video. By the way, don't forget to hit the subscribe button and support the channel. And thank you for watching. I will see you next video. Bye.